Hello, Honors Math 3. Today is Thursday, April 30th, last day of April. We're going to evaluate a couple limits based on some of those limits of trig functions we saw the other day. Anytime this is the same, that 10x and 10x, I can let that 10x equal some other variable, let's say theta. And please notice then, as x approaches 0, 10 times 0 is 0, theta also approaches 0. So then I can rewrite this limit as the limit as theta approaches 0 of, let 10x equal theta, tangent theta over theta. And then you should recognize one of that as one of those you're going to memorize. Tangent x over x as x approaches 0, which is just 1. If you notice, this next function is undefined when x is equal to -2, so I do have to do a little work there. Okay, so think about how I can evaluate that limit even though that denominator is undefined at x is equal to -2. I'll pause. Notice to do a little work with that limit, I'm going to factor it. Once I factor, I have a common factor, and that actually removes that point of discontinuity, so that I can evaluate that limit. Now I can plug in -2 to the numerator, I get -5. Plug in -2 to the denominator, I get -7. Function values are approaching 5/7, even though there is a hole at x equals -2 in that rational function. Okay, this third case, these are not the same. If this was just the same, it would be like this first problem, and this would be equal to 1. But those are not the same. So that's not just equal to 1. Okay, watch this cool trick, and you might say, Mrs. Anchuk, I wouldn't have come up with that. That's all right. I'm going to give you a couple little tips and tricks here. I'm going to force these to be the same. Watch this cool trick. I'm going to multiply numerator and denominator of that fraction by a creative factor, and that creative factor is going to be 3/2. If I multiply the denominator by 3/2, those 2's cancel, and I'm left with 3x, which is what I want. So if I multiply the denominator by 3/2 to force that 3x, I also have to multiply the numerator by 3/2. This becomes the limit as x approaches 0. I'm just rewriting it really, of 3/2 sine of 3x when I multiply that numerator, divided by those 2's cancel, and I'm left with that desired result. This I memorized, and that is just equal to 1. So this is equal to the limit as x approaches 0 of 3/2 times the limit as x approaches 0 of this, which I wanted, sine of 3x over 3x. This is equal to 1. This is equal to 3/2, and I'm left with 3/2. All right, using some of those trig limits. Alrighty, we continue to talk about this important concept for calculus, finding the slope of a tangent line. Slope of a tangent line to a function. So here's my random function f of x. And we're going to find the slope of a tangent line at some point C. Okay, imagine at that point C, what is that function value right there, or that ordered pair? That would be an ordered pair C, and my function value is what I get when I plug in C. And then I'm going to find some other point near it, let's say x. And if I go up to the function at that point x, then that ordered pair is x, f of x. Alrighty, and please notice as my x value gets closer and closer and closer to C, the slope of this secant line, as x gets closer and closer and closer to C, the slope of that secant line approaches, if I get closer and closer and closer, approaches the slope of the tangent line. Let me jot that down. So again, as those x values get closer and closer and closer to C, that difference between them gets smaller and smaller and smaller and smaller, the slope of the secant line approaches what we are looking for, that slope of the tangent line. Alrighty, please notice, how do I find the slope of that secant line? Change in y over the change in x. Change in y values are function values, f of x minus f of c, f of x minus f of c, over change in x values, which is x minus c. Okay, so that's how we would find the slope of the secant line. That means to find the slope of a tangent line, I can actually use a limit. As x values get closer and closer and closer and closer to c, that slope approaches the slope of the tangent line. I'm going to use the subscript notation. The slope of the tangent line will equal the limit as my x value approaches c of that slope, f of x minus f of c all over x minus c. Alrighty, if I can actually find that slope of the tangent line, if I can actually evaluate that limit, then I can write the equation of that tangent line. So we'll also find the equation of that tangent line. That's an important concept next year. I will typically use point slope form to find the equation of that tangent line with the slope that you find and the point. What is the point right there? Right there, right there. That point is input c, output f of c. Becomes y minus the y coordinate, f of c, is equal to the slope times x minus the x coordinate, which is c. And we'll find the equation of that tangent line. Alright, let's try it just so we have a sense of what we're finding here. Find the slope of the tangent line for this function at the ordered pair 1, 0. And we're going to graph f, the function, that function, and the tangent line. Alright? Okay, first I might take a moment to graph this function f just so I have a sense of what's going on here. So that's f of x is equal to, I'm going to factor, which is x squared times x minus 1. That gives me my x-intercepts. And my x-intercepts are at 0 and 1. Let me plot those. 0 and 1. Do you remember end behavior for an odd function is going to go up, down to the left, and I'm going to have a bounce at x equals 0. Okay, so let me give you a little sketch here. It looks something like this. Up to the right, bounce at 0, down to the left. Okay, so there's my function. Let's see. If you were to find the slope of the tangent line at 1, 0 right there, does the slope look like it'll be positive or negative? If you could skim a tangent line at 1, 0, would that slope be positive or negative? Have a sense before we find it. And let's find the slope of the tangent line, which is the limit as my x values approach 1 of the slope, which is f of x minus f of, in this case I'm approaching 1 minus f of 1 all over x minus 1, okay, which will be the limit as x approaches 1 of, what is f of x? F of x is that function, x cubed minus x squared, minus, what is f of 1? Oh, we're given right here. F of 1 is equal to 0, minus 0, all over x minus 1. I can't plug in 1, so go ahead and simplify this and factor. Let's clear up that problem spot. Okay, that 0 goes away. I can factor out an x squared, factor it out. I can eliminate that problem spot. And now I can plug 1 into that limit. It's defined at 1 once I get rid of that problem spot. 1 squared, which is 1. Alright, and that's the slope of the tangent line. So I've got the slope of the tangent line as 1. I'm going to plug in the point 1, 0, and this becomes the equation of the tangent line. And the equation of the tangent line, y minus 0, is equal to the slope, which is 1, times x minus 1. Or y is equal to, I might just distribute 1x minus 1. And there's the equation of my tangent line. Okay, let me graph that. Let me graph that with my original function f of x. I have a y-intercept of negative 1. I have a slope of 1, up 1 over 1. And there's the equation. If you guessed the slope of the tangent line was positive, you're right. And there's the equation of that tangent line. And the slope of the tangent line at that point is 1. Alrighty, let's continue on. Alright, you may have heard this term before. The slope of a tangent line is so important, we give it a special name. It's called the derivative of a function at that point C. The derivative of a function at C, written f prime of c, we read that, is defined as f prime of c, the derivative of that function at c, is equal to the limit, we just defined it, as x approaches c, of f of x minus f of c all over x minus c. And that is that slope of the tangent line. Find the derivative. Find the derivative of this function f of x at x equals 1. The derivative is the slope of the tangent line. What is f prime of 1? That is the limit as x approaches 1 of f of x minus f of 1 all over x minus 1. Plug into that if you would. Okay, I plug in the function f of x, which is negative 4 plus 3x squared, minus f of 1. When I find f of 1, it's negative 1, so minus a negative 1 all over x minus 1. Let me clean that up, which is the limit as x approaches 1 of, and I put that 3x squared out front, minus a negative is plus, minus 3 all over x minus 1. Go ahead and try to factor that. That's the limit as x approaches 1. Go ahead and factor. I'm going to factor out a 3. I'm going to factor that difference of squares. I'm going to remove that problem spot. I have a hole. And now I can plug 1 in. 1 plus 1 is 2 times 3 is 6. That means that f prime of 1, the slope of the tangent line at x equals 1, is 6. Okay, let's try that with a cosine curve. If my function is y equals cosine of x, find the derivative at x equals 0. What is f prime of 0? The slope of the tangent line at x equals 0 is the limit as x approaches 0 of f of x minus f of 0 all over x minus 0. Okay, start rewriting. F of x is cosine of x. F of 0 is cosine of 0, and cosine of 0 is 1, so that's f of 0. Wait a second, isn't that one we memorized? As x approaches 0 of cosine x minus 1 over x is just 0. Okay, so this is one we memorized from the other day, or will memorize. So that means that f prime of 0 is equal to 0. I like to think about it. Here's my cosine curve. There it is. The slope of the tangent line at 0 is 0. Here's x equals 0. I'm going to skim a line to my cosine curve right there. And would you look at that? The slope of that tangent line is 0. So it does make sense and it does check out. Alright, let's look at a little application of our derivatives. Okay, an object is dropped from the top of a tall building and it travels this many feet in the first t seconds. So here's seconds and here's feet. And as time passes, it keeps dropping faster and faster and faster and faster. So there's that function, f of t. You're asked to find the average speed of the object between the first and fourth seconds. Average speed, if you remember, is just the slope. To find the slope of a function, that's f of b minus f of a all over b minus a. In this case, just function values will be f of 4 minus f of 1 all over 4 minus 1. Grab your calculator and find that slope. When I plug into the slope formula, this is the change in y, 240 feet, over the change in x, which is in seconds. And the average speed between seconds 1 and 4 is 80 feet per second. But if we're asked to find the instantaneous speed right at 4 seconds, that instantaneous speed is the slope of the tangent line. And that slope of the tangent line, again, is the derivative. And now from what we've seen, how do we find the slope of the tangent line? F prime of 4. Refresh your memory. How do we find the slope of a tangent line? In this application, that's the limit as t approaches 4 of f of t minus f of 4 over t minus 4. Can you start plugging in those values? I plug in values. I factor. Continue. Get rid of that problem spot. plug in 16 times 8, and the derivative is 128